This is Linear Functions Part 2, and we're talking about solutions of linear equations in two variables. And these solutions come in the forms of ordered pairs. An ordered pair has an x-coordinate followed by a y-coordinate. And these two coordinates, when placed into our linear equation, make a true statement. The graph of a linear equation in two variables is the set of all points in a coordinate plane that represent all the solutions of the equation. Sometimes those points are distinct, separate points, and other times they are connected. If a problem has what is called a discrete domain is a set of input values that consists of only certain numbers in an interval. Let's look at a problem that represents a discrete domain. So here we have the linear function y equals 15x represents the cost, y in dollars, of x tickets for a museum. Customers can buy a maximum of 4 tickets. They want to know what the domain is, if the domain is discrete or continuous, and they want us to graph the function using the domain. So the first thing that we want to do is try to understand this problem a little bit better. So I'm going to make an input-output chart here. So I know that I can buy 0 tickets as a customer. I could buy 1 up to 4 tickets. My function says I'm going to take my input and multiply it by 15. So 15 times x. So if I buy 0 tickets, 0 times 15 will cost me $0. 1 ticket is 1 times 15 or $15. 2 tickets are 30, 45 for 3 tickets, and $60 for 4 tickets. The domain is 0, 1, 2, 3, and 4. Those are my input values. They're discrete. I can't buy 1.5 tickets. I can't buy 3.5 tickets. Therefore, these are distinct individual input values. When I go to graph them, if I buy 0 tickets, it's $0 or the 0.00. 1 ticket was $15 or the 0.1 comma 15. And I see they are all distinct individual points. So I have a discrete domain here. A continuous domain is a set of input values that consists of all the numbers in an interval. So let's look at another problem that is an example of a continuous domain. So we have a cereal bar that contains $130. The number C of calories consumed is a function of the number B, bars eaten. They want us to find the domain, state whether it's discrete or continuous, and graph the function using its domain. So to start off, I created an input-output chart where I could find some values that fit the situation to better understand what's going on here. So if I eat 0 cereal bars, I will have consumed 0 calories. 1 bar is 130 calories. 2 bars are 260 calories. If I eat 2.5 bars, I've eaten 325 calories. 3 bars are 390 calories, and I could keep going, but this helps me understand what's going on here in this problem. Since I can eat part of a cereal bar, the domain here, the number of bars eaten, is anything greater than or equal to 0. This would mean it's continuous. I can eat a half a bar. I can eat a quarter of a bar. So when I go to graph these, if I have 0 bars at $0 or the 0.00, 1 bar is 130 calories or 1 comma 130. 2 bars is 260 calories or 2 comma 260. And here's my other points, but I can draw a line connecting them because this is a continuous scale. I could eat 2 1/4 bars. I could eat 4.5 bars. So it is a continuous domain.